Alright, so this week we're going to be doing some stuff with measurement. We already did something in class. If you're watching this video early and we haven't gotten to the measuring activity yet, some of this might be a little abstract for you, but it should make more sense after we do that. But because this is a science class and it's a physics class, we're going to do tons of labs, you're going to be doing tons of measuring. So you need to know what you're doing when you're measuring. Alright, how to interpret things if you know you're kind of doing it right, or maybe if it seems like you're constantly getting the wrong thing, and then how you might be able to adjust that. So, whenever you take a measurement, if each person in your group did the measurement, you very well might end up with 4 different measurements. Or you looking at the exact same thing twice might end up with 2 different measurements. There's always some variability, okay? Because what's happening is whatever tool you're using, there is some sort of estimation that is being done. That very last digit should be an estimated digit, okay? Even an electronic balance, it has that estimation built in for you. Alright, so if you look at the scale on an electronic balance, its last decimal point, that is an estimated point. And sometimes you'll see that decimal point fluctuating, which means the scale isn't sure which one to choose. Okay? So, some basic information known about measurement is that in measurement land, alright, in this class, we have certain standards that we're going to use, and they're known as international standards. The basic unit for length, we're always going to refer to that as meters. Basic unit for mass is always going to be kilograms, alright? Notice it's not just the basic gram, but kilograms. We'll get a little bit more into detail with this later in the week. Time, basic unit is seconds, and then volume in here we're going to be using liters, which is also the same thing as a meter cubed. We really won't use volume much, that's just something for your own information. But these 3 we will use constantly. So, true value is the accepted, the known value, the theoretical value. Alright, what it's supposed to be. Alright, like for example, it is a known or accepted or true value that water boils at 100 degrees Celsius. Or if you convert that to Fahrenheit, it's 212 degrees Fahrenheit. Hopefully this is something you guys have heard before. Alright, certain things like, a meter stick, like that tool is supposed to be exactly 1 meter. Okay? So true values are also sometimes referred to, a third thing is a calculated value. So if you're using a theoretical, like solving an equation before you do an experiment, that calculated value is your theoretical value or what you expect to be your final answer. Okay? And then obviously your experiment oftentimes doesn't end up quite matching that. So, when we're doing an experiment, we need to factor in accuracy and precision because these things will affect the outcome of our experiment. Alright? The 2 words sometimes are used interchangeably, but that is an incorrect usage of them. Alright? So accuracy is related to that whole true value idea. How close your measurement is to whatever your true value, whatever your calculated value would be. Like if you're measuring boiling point, how close your measured value is to the boiling point. Alright? If you're getting 120 degrees, that's probably not very accurate. But if you're getting 101, that's much better. Okay? Precision, on the other hand, is related to how close your measurements are to one another. And this especially relates to the tool that you use. Okay? Some tools have a high degree of precision, which means they're going to have a lot of these little tick marks. They're going to go to many decimal points. Okay? Some tools aren't so great. All right? Here, barely any tick marks. You can only tell for sure if it's between half or a whole number. Then you're estimating anything beyond that. Okay? So the more precise your tool is, typically the more closely related your measurements are. So say, for example, in temperatures, a very, very precise tool, you might sit there and be getting between, say, 99 degrees and 100 degrees for all of your measurements, because you're going to get 99.82, 99.92, 99.98, 100.02. Alright? Whereas if you say you have a tool that only measures to the nearest degree, you're probably going to get 95, 102, 97, okay? Both are measuring accuracy because they're really close to that 100 degrees, but one is much more precise than the other. Right? Precise tools tend to have less variability. Okay? So another kind of visualization on this. Here we have, if the bullseye in the center represents the true value. Alright, you've got 3 arrows that are real close to each other and they are right on the bullseye. Okay? That's going to be accurate because you're getting the correct value and they're really close to each other. Sometimes you can have a tool that's not accurate but precise. An example of this is sometimes you'll notice on a ruler, some rulers start right at the edge. Alright, so your little tick marks and 0 is the very edge. Other rulers, your 0 might be here and then it starts. So sometimes inaccuracy can be caused by you. So make sure you pay attention to your rulers and you're actually starting at the 0 mark. Alright, these sorts of rulers have a greater tendency to show precision because both of these rulers had the same number of tick marks, the same number of precision, but if you use the second one wrong, then you're not going to have as much accuracy because you're going to always be off by whatever this little amount right here is. Okay? And then the last bullseye is showing you we've got 3 measurements that are all over the place and they're nowhere near the bullseye. So we have a lack of precision and a lack of accuracy. Okay? What we want to be getting in this class is as close to here as possible. Alright? We don't want errors to be coming in. Most of our tools are fairly precise. So when you start getting stuff like this, there's a chance a human mistake is happening. Okay? So especially when we were doing our measurement activity yesterday in class, or actually that should have been today in class, you need to consider the uncertainty. Okay? So uncertainty relates to precision, and it's related again to your tool. Alright? So the ruler that had the 0 mark and the 10 mark, there was a lot of uncertainty. A line right here, you might sit there and say that's 5, that's 6, it's 7. Huge range of variability. A lot more uncertainty. Okay? Whereas the tool that has the one that had the 1, 2, 3, 4, and so on, labeled everything. Now we can tell, okay, you know what, we can definitely narrow that down to between, say, 4 and 5, right? Or maybe just over 5. A lot less uncertainty in how long that line is, okay? So uncertainty and precision sometimes can be related to each other, but uncertainty is an actual amount. So it's like your uncertainty on this tool is probably going to be plus or minus 1 centimeter, whereas your uncertainty on the 0 to 10 tool is probably more like plus or minus 3 centimeters. Alright, so uncertainties are amounts. They can be calculated. It's something we're not going to specifically get into in here, but definition you might want to know. And last thing we need to go over is error. We will have lots of error in this class. Most of the time it's not due to precision. It's going to be due to something creating inaccuracy in our measurements. Alright, so there could be human error, But we're going to avoid that as much as possible because you are going to be very, very careful with your measurements. All right. There's also going to be systematic error, which is just stuff that's built in. All right. Stuff like friction. We don't have the money to buy tools that are frictionless or near frictionless. So a lot of times your error will be off by a certain value, and that value is going to be related to the friction in the surface that the experiment is taking on. Okay, but you need to be able to find your error. All right, so basic error is whatever your true value is minus your experimental value. So say the boiling point. We know boiling point is 100 degrees, and our experimental value is 90 degrees. Our error is 10 degrees. Okay, so this part's easy. The more often than not, because this number, a 10-degree difference may or may not be a big thing. But say the true value is 1,000 degrees and you get 990 degrees. Again, it's still a 10-degree error, but that's actually a lot less error. So indicative value related to calculating error is actually your percent error. All right? In class, if you can maintain under 10% error, that means you're doing a really, really careful job, and we have some of the best tools. That won't always be possible, but that is a good aim to go for. All right, so again, let's try again. We have our true value being 100 degrees. We're going to subtract our experimental value, 90 degrees. All right, and then that's going to go on top. We're going to divide that again by the true value. All right, so we have 10 over 100, which is 0.1, and then our last thing is multiplying by 100 to make that a percentage, so we have 10%. All right, one rule for this is, say up here, you get a negative number, always make that positive. There's no negative error. Positive. Okay, there's no negative error. Kind of think about this as being this top part being an absolute value bars. Sometimes it's written that way. So if you ever see an extra just straight bars, that just means absolute value, which means if you get a negative number, just make it positive. Okay? So that's it for this. Do the online assignment and make sure you have some notes with you in class tomorrow.